So you guys have always wanted to know why you have these lovely, beautiful, bright yellow, in fact, it's called school bus yellow, graphing calculators. Well, the reason is sometimes it's nice to be able to find a line of regression or like a quadratic regression, so on, when you're given data. So what we can do is we're going to use our linear regression feature. I'm going to show you how to do that, but also if you need them, you can always go into your Appendix A for your specific keystrokes. All right, so say we have median purchase prices in thousands of dollars for new one-family homes in the United States from 2000 to 2008 are given by the following ordered pairs. So what we need to do is we need to plug all of these ordered pairs into our calculator. Sorry, I'm skipping ahead here. Just get so excited. All right, so for A, what it says, use the regression feature of a graphing utility to find a linear model for the data. Let T represent the year with T equals 0 corresponding to 2000. So what that means when we plug these values into our calculator, we're not going to plug in a 2000. Instead, what we're going to be doing is we're going to be plugging in a 0. For 2001, we're going to be plugging in a 1 and a 2 and so on and so on. So here are your keystrokes you need to plug this into your calculator. All right, so say we are at our beginning here with nothing. You need to go to your stat button, which is just 2 keys to the right of your green button. Hit the stat, and it will give you this menu. The only thing we're ever going to use on this edit menu is number 1, edit. We're not going to use sort, D, clear list, setup editor. We're just going to use 1. So you click on 1. We have all these values in here. Well, how do we get these? Well, these are actually the values we need, but I'm going to redo this so you know how to plug them in. But this should be your final product. Now, I want to clear this entire list of numbers. So your calculator may have some numbers in here. If you go up, highlight L2, hit the clear button, and then hit enter. That gets rid of that list. So that means when you go to the left one and up one, hit clear and enter. That gets rid of that list. So what we're going to need to put in are all of these numbers. 0, 1, 2, 3, 4, all the way up to 8. So in order to plug these into your list 1, that is your X column, your L2 is your Y column. So we're going to plug in 0, hit enter, 1, enter, 2, enter, 3, enter, 4, enter, all the way down until you get to 8. Actually, you hit 8. Enter. And then now we need to plug in all of our values on the right. So with 0, the number that goes along with 0 would be a 169. Enter. You don't have to put the point 0. We get a 175.2. Hit enter. And then after each time you have to hit enter or else the calculator will not accept it. 187. That's not good. All my thugs know what I'm talking about it. 221, we got a 240.9. We also have a 246.5. How about 247.9? That matches up with the 7. And with the 8, we get a 232.1. So it looks like the value went down a little bit. All right, so now what we want to do, these are ordered pairs. These are points. We want to see where they are graphed. So if we just go to our graph, those don't look like ordered pairs. In fact, I have a graph on here. Well, it's nice because my calculator is not an actual calculator, but I can see I have a point here, or I have an equation. Go to your y equals, clear that out. We don't want the equation. Hit enter, gets rid of our graph. Go to your graph, no graph. Still no points though, so that's a problem. So here's what you do. We have a scatter plot of points. So you're going to go to your zoom button up here on the top in the middle. Hit zoom. You don't hit 6 for standard. You don't hit 0 for fit. However, you may notice something right before the 0. Oh my gosh. It's called zoom stat. This is what you need. Whenever you plug anything in to tables using your stat, you have to use 9 for zoom stat. So it'll give you your graph. Oh my gosh, no, it won't do that either. What did we forget? Well, we don't have our plots on. So you go to y equals. I know there's a lot of keystrokes. Good thing you can always pause this, rewind it, watch it over and over multiple times. What you need to do is you need to go up. So if your cursor's on Y1, go up plot 1, hit enter. And now you should have a highlighted plot 1. Hit zoom and then 9 for zoom stat. Hit enter. Oh my gosh, this is the coolest thing in the world. There are your points. There are your 9 points. So what it says is use a regression feature. Well, we're not even done because we still need to find a linear model. A linear model. That means we need to find an equation of the form y equals mx plus b. So what we're going to do is we're going to go back to our calculator and we need to hit our stat button again. And we're not going to use anything in the edit menu, but we are going to cursor over to our calc menu. Once again, that's like our calculate menu. However, it is different than this calc menu when you hit second trace. We want to find a linear regression. Well, if you go down to number 4, you're going to find a lin reg. Now they use ax plus b, but that's the same thing as mx plus b. A quad reg, a cubic reg, a quartic reg. You have all kinds of other regs down here. And we will use some of these here in the future. Notice this ln reg is an a plus bx, so we don't want to use that. Here you have an ln, that's a natural log, exponential, on. Well, we want the ln reg, where the ax plus b is, and so we're going to use 4. All this, your x's should be your L1, your y's should be your L2, this should all be here. Go down to calculate, and hit enter. Here's your equation. So the equation that we are given is y equals ax plus b, but your a is a 10.57, your b is a 170.52. Now if you don't have these values, hold on a moment and I'll show you what those are important. So we finally answered a. So we're going to say y equals 10.52 times t plus 170.5, and I don't remember the last number. 0.52. Oh, I got the 5. That's a 5.7 there. 0.57 t. This is a 0.52. Now, the cool thing about this is a line that will actually go through your data points. So we want to know how closely does your model represent the data. Well, if you go back to your calculator and type y equals, and we're going to type this equation in, 10.57x instead of t plus 170.52 to hit enter, find your graph. There is your line that we were given, that your calculator found. So you didn't have to. You just have to remember the keystrokes, which could be tougher for some of you. I know, it's difficult. So that line looks pretty good. It goes through the data points. Well, what really tells you how good your line is what we call an R value. This is a correlation constant. Okay, this is called your correlation constant. And what we should know is the closer the R value is to 1 or -1, the better your model fits your data. So what we would say is how closely does it represent the data? I would say, well, I don't know, what's my R value? So what you have to do is you have to go back to your stat button, go over to your calc, you have to find your lin reg again, so we're gonna hit 4, go down to calculate, and here's our R and our R squared. Our R value is a 0.9222, on. If you do not have this, then the way to find your R value, if it's not on, is you need to hit second 0 because of your catalog. We're trying to find a diagnostics on, so we're going to hit D, or you can cursor all the way down to your D's, and we need to go to diagnostics on. Almost there. There's diagnostics off. We want diagnostics on, so we're going to hit enter, and then hit enter again. Now you're done. So if you go to stat, over to your calc, Hit 4 for your linreg. Calculate. You should have an R value. If not, you need to tweet me, whatever your video, something, whatever, but you need to follow those steps. So here's your R value. So I would say it fits your data fairly well. So we might say the model, I'm a model, you know what I mean, fits the data fairly well. Now, if it was up closer to a 0.98 or a 0.999, I would say that model fits the data very well. So what we need to do is we need to state your R value. Well, our R is approximately 0.9223. So like we said before, the model is a decent fit, but it's just not perfect enough. So that doesn't mean that our points are wrong. That just means that our data points, which are proven, don't follow a great linear model. So I would say the model is decent, but not great. So I apologize for the lengthy example here, but you do need to know these keystrokes. You need to know how to do this problem. Because on a test, I'm not going to say, oh yeah, come up and let me do your whole problem for you. Psych. Not going to happen. So I hope you guys enjoyed all of Chapter 1. That concludes 1.7 and Chapter 1.